In this video, we're giving OpenClaw the automation skill to see and hear what's happening in your home and send you smart alerts with AI-powered analysis by connecting a camera to Frigate for AI detection, faces, pets, cars, and sounds. First, we need to build the communication backbone. To connect everything together, you need an MQTT broker. It's the central server in the MQTT protocol, designed specifically for IoT devices. It receives messages, forwards them, and manages device connections. Without it, Frigate can't talk to Home Assistant. Once you have your MQTT broker running, move on to Frigate. Frigate is a complete local NVR designed for Home Assistant with AI object detection built in. This is the eyes and ears we're giving OpenClaw. For both MQTT and Frigate installation steps, check the recommended video above. I won't repeat it here. Once both are installed successfully, let's focus on the Frigate configuration file. This YAML file is where you tell Frigate what to watch for, what to record, and how to communicate with the rest of your system. Add the MQTT section with your broker's IP address, port, username, and password. This is the bridge. Without it, Frigate runs in isolation, and Home Assistant never sees those AI detections. Then, enable the core features: record, snapshots, and detect. Record keeps footage, snapshots capture key moments, and detect runs the AI analysis. For the ears part, add an audio section and enable alarm sound detection. Frigate can listen for specific sounds, like alarms. For the eyes part, turn on face recognition. This is what lets Frigate identify specific people: your dad, your kids, whoever you train it on. It's not just person detected anymore. For vehicles, enable license plate recognition. Now, Frigate can read plates and alert you when specific cars arrive or leave. Your car, your neighbor's car, random vehicles, you'll know the difference. For the camera itself, give it a custom name. Let's call ours Test Camera. Enable audio recording. Paste in your camera's RTSP URL, username, and password. Then assign roles: detect, record, and audio. Tell Frigate what objects to track: person, car, dog, cat. You can add more, but start with these. Save the config, restart Frigate. Once Frigate is back up, open the web UI. Head over to the face recognition section and click Add Face. Give it a name, like Dad, then upload a clear front-facing photo with no obstructions. That's it. Your face library now has a recognition label to work with. Now, let's talk about Frigate's newer classification feature. This is where you can train custom models for specific objects, like your pet. Start by pointing your camera at your cat and wait until you see the cat logo appear in the top left corner. That means Frigate has detected it. Do this multiple times to collect enough samples. Then, click the Explore button on the left. You'll see all the samples you've captured. Next, go to the classification page and click Add Classification. Create a new model, call it My Cat. Set the type to Object, label to Cat, and classification type to Sub-label. For class names, you need at least 2. I added My Cat and Cute Cat. Then select the sampled images you just collected as your training data. Hit Continue, and Frigate will start training the model. Once training completes, check the logs. You'll see a new model listed, My Cat, ready to use. If everything worked, Home Assistant just discovered a bunch of new entities. Frigate pushes every detection as a sensor entity: one for faces, one for license plates, one for sounds, one for each object type. Let's grab one as an example, the alarm sound entity. Copy that entity ID. You'll need it for the next step. Do the same for the other detections: face recognition, license plates, and classification label. Each one is a sensor that OpenClaw can now monitor in real time. With all the sensors ready, here's where it gets interesting. We're going to build this step by step with OpenClaw, starting with a single entity, getting it working, then gradually adding more entities and more complex features on top. Here's what I did. You can send OpenClaw a detailed, structured prompt like this. Create a Node.js script that monitors a single Home Assistant sensor entity for state changes via WebSocket. Monitor exactly one entity, alarm sound. Connect, authenticate, subscribe to state changes, log them to console, and auto-reconnect on disconnect. That's it. No complex setup, just a clear task. A few seconds later, OpenClaw created the script and confirmed it was ready to monitor the sensor for state changes. I ran the script, triggered a sound, watched the logs, and there it was, state change detected. No back and forth, no tweaking, no second attempt. OpenClaw nailed it on the first try. Once that's working, the next step is to get notified when the alarm triggers. Here's the prompt I used. Add IM group notification to the script. When the alarm triggers, send a text message with timestamp. That's it. No need to rewrite everything, just the new functionality. A few seconds later, OpenClaw updated the script. I ran it, triggered a sound, checked my IM group, and there it was, alarm sound detected. With real-time alerts working, the next step is to get visual context when the alarm fires. This time, I sent OpenClaw a prompt like this. Add snapshot capture to the script. When the alarm triggers, grab a snapshot from the camera and attach it to the IM group. Simple addition. OpenClaw handled the rest. Moments later, the script was updated. I tested it, triggered a sound, checked my IM group, and the alert came through with a snapshot attached. Now you're not just getting a notification, you're seeing what's actually happening. With visual context in place, it's time to make the system smarter by understanding what it sees. The prompt for this step: add AI image analysis to the script. When a snapshot is captured, send it to the main agent for analysis and include the report in the IM alert. Straightforward extension. OpenClaw integrated the AI layer without breaking existing functionality. I tested it. This time, the IM alert came through with the snapshot plus an analysis report. You're no longer just seeing what's happening, you're getting context about what it means. With AI analysis delivering context, the final step is expanding coverage across all your sensors. For the final expansion, I sent this prompt. Extend the script to monitor multiple Frigate sensors, face recognition, license plates, and pets. Each detection should trigger the same workflow: snapshot, AI analysis, IM alert with full report. That's all it took. OpenClaw expanded the script to handle every sensor. I triggered each sensor one at a time. Every alert came through with its snapshot and analysis. The system is complete. OpenClaw now has eyes and ears across your entire home. At this point, you've got a working automation, but it's still just a script. Let's make it reusable. So I sent OpenClaw a prompt. Convert this automation script into an OpenClaw skill. About a minute later, OpenClaw responded, skill sensor automation analysis created and ready to deploy. That's it. What started as a one-off script is now a reusable skill, ready to deploy, share, or modify for different scenarios. I've bundled everything from this build into a guide, link in the description. What would you build with this? Drop your ideas in the comments. And if this helped, a like and subscribe keeps the channel growing. Thanks for watching.